Hi, thank you for showing an interest. My name is Bart and I'm here to talk about LODs, which doesn't seem at the surface the most complicated topic. You hide one thing and show another. Quite basic. What could possibly go wrong? Well, that's basically what it's about today. First, a small overview and also what Godot has to offer. I'm not going to go over that, you can read. I cherry-picked some interesting cases, of course. I can't possibly cover all the options and all the combinations, but there's some interesting things going on. Because sometimes you do everything right, and it looks wrong. And the even more nasty one, you do a lot of things wrong, they cancel each other out, they look right, but you're losing performance. Interesting. So right off the bat, I'm going to start with Geometry Instance 3D, which has a visibility range property, actually on the node itself. You can set basically a begin and an end of where it's visible, not exactly brain surgery. So let's see how that works, and we're going to start really simple, a hard swap. You want to swap something out for a different version, which is basically what LOD does. So we set the end of one node and the begin of another node to the same. Well, look at the image to the right. And what could possibly be wrong, right? Let's have a look at the result. Going front to back, it swaps out. Yay, it works. Life is good. Oh, if you're new to LODs, you might also be a bit surprised that going left and right also swaps them, while the distance doesn't change. We'll cover that in a minute. But life seems good, right? Everything, you've tried this. Actually, this sample is pretty much one-to-one also in the documentation. However, now I'm taking a different mesh, a real-life mesh. This is from a tree. It uses cards, and this has small leaves, and the next LOD has whole branches as cards. You'll see the difference in a second. Let's see what happens. Still seems to work, right? Although you might notice sometimes there's this little flicker. You're like, More interesting though, if you do it really slowly and left to right, what you're going to see is, well, hey, what's happening there? It's drawing both of them at the same time. And this is on the right side of the screen. The plot thickens. Let's go to the left side of the screen. The opposite happens. Oh, there's nothing. And of course, in real life, you will do this at a larger distance and it will be less apparent. But especially if you have like foliage or smaller objects, you won't always notice it as that. But every now and then you might be like, what's going on there? So the background of that, it's not a bug, it's documented, is for both the beginning and the end, the distance that's being calculated is from the camera to the center of the instances AABB, the bounding box. So what happened with our documentation sample, with the generated meshes, which are perfectly aligned around their origin, the center of the bounding box is at the same spot. But with real-life assets, almost guaranteed, the position will differ. There's several ways around it. There's like 4 or 5. Not enough time to go over all of them. One of them is to combine with visibility parent function, discussed later, or set custom bounding boxes so that they're all equal. And of course, then you take the largest one. So that's gotcha number 1. But we're not there yet. Okay, I briefly touched on it. If you don't understand why moving left and right also changes the LOD and not just going back to front, because mostly when you think about this, you associate it with distance, back to front. The reason for that, and also for what we just saw, where we have different behavior on the left side of the screen and the right side of the screen, is actually the camera position. Because what you perceive as distance on the monitor are the little black lines from the near plane of the camera, while the distance to the camera position is below that. And this is on the left side of the screen. If we look at the A and B, now currently A has a longer line, the dark gray line. If you shift to the right side of the screen, now B has the longer line. So basically, If these were the small two offsets of our AABB centers, the polarity swapped, and that's why there was a different behavior on the left and the right side of the screen. Short detour. So basically, this is in Godot throughout, no matter what LOD variant you use. It uses what they call a spherical selection mode. Because at the same distance, if you plot all the points, well, you get a circle. Why this is relevant and good to know, we'll touch on later as well. Okay, still on geometry instance and the visibility ranges, you can enable fade modes. And in the context of using multiple nodes, I'm going to skip over using that for a single node, because there's nothing much to tell there. But you can introduce a fade mode, and this enables a few properties. The margins, we'll touch on that in a second. Okay, first be aware, this will help the transition. It will not be a hard pop, but we'll use alpha fading to fade between the two, making it look better. Right off the bat, a real common case for using LOD is foliage, and a lot of foliage assets, they all already use the alpha channel, so it will clash, it will look bad. How it will look bad differs between the assets and the materials used, but that's a bit of a gotcha. It doesn't matter that much, because this is hardly ever used. And the reason for that, at the bottom, copy from the documentation, it uses transparent rendering, and that is detrimental for performance. If you're a bit new to rendering, if you try this in the editor just with one asset and you try it, you won't see a big difference. But it's in context of a larger scene, where the impact becomes much, much larger. And the reason for that is it has to do with ordering, without going into further detail. But we're going to try this. So, the docs are excellent, but the picture is often more easy. When setting up LODs or transitions, it's much easier to think of, just like your favorite audio or video editor, setting up a crossfade, and only instead of time, you've got distance. So we make them overlap, and we fill in the margin properties to be the same, and you get a crossfade. Now, no mystery here, it will fade. But as you can see, there's a little side effect. Because as to surprise to nobody, using alpha blending for fading, causes, exactly that, alpha blending. So if it's halfway the transition, it becomes transparent. You can see the horizon go through it. But again, not a big deal, because this is hardly used because of the performance impact. The reason, though, why I zoom in on this one, because again, there's no mystery here. You can figure it out. The main takeaway here is it becomes transparent, not because we want it to, it's just a side effect of the fade being used. Okay, so what does perform? Looking at base material 3D, and by extension standard material, there's also properties that you can set a distance fade. It doesn't have a margin, so here you're limited per node for a fade in or a fade out by swapping the two values. You can select a couple of modes. Pixel alpha will look pretty much like what we just looked at. Again, not very popular, large performance impact. What performs much better is pixel jitter. Well, setting this up, again, not exactly brain surgery. What could possibly go wrong? We create an overlap by swapping the two values over the two nodes. Let's see what it looks like. Well, as far as dithering goes, the first time that I saw this, I was like, it doesn't look half bad. But when I actually tried it in a production environment, in a game I was making, some things were off. And then I went looking at videos on YouTube of other people's games, and I saw kind of the same things. So what was going on? It worked, but... Well, first thing you notice, if you put them next to each other, alpha blending and dithering, it's not just the dithering, of course, the technique looks different, but there's other subtle differences, or not so subtle. Because left, they go through each other, but on the right, it's actually intersected. The depth buffer is working. So that's quite a big difference. Of course, now it's very apparent if you use real assets, which have closer resemblance, it will not be that pronounced. However, if we were to rotate this view, I'll be damned. It's also transparent. So basically what the dithering is doing, it's kind of emulating the alpha blend too well. Because with the alpha blend, it was a side effect of the technique used, but here we're using a different technique. That's something we want. You know, your tree or your bush is fading out, and behind it is a red fire hydrant, and it starts shining too. Not very nice. So what's going on? Zooming in on a little bit of that frame is what's happening. Dithering overdraws. And what do I mean by that? Both objects, regardless of the direction, are actually using the same dither grid, leaving the holes unused. So what can we do? Well, let's have a look. Go to material, convert to shader material. In the shader, we can see record being used. If you're not into shaders, basically that means screen space coordinates are being used, which is kind of the giveaway that, okay, here's the dithering pattern. If we add this, notice the little -1, 1 minus. If you do this on just one of two of the materials, so basically what's going to happen, if you look in detail, it's not the exact same part of the frame where I took the screenshot, unfortunately, but you get the gist of it. What's happening now no longer overdraws. Yellow is no longer overdrawing blue, but it's filling in the gaps. To make it more clear, let's see them side by side. On the left side is the original dithering, and on the right side is this slightly tweaked on one of the objects. So now it's actually ghosting, and you no longer see the horizon where the two LODs overlap. It becomes more clear when you rotate. The old one, yeah, you can see right through. And the other way around, aha. So life is good, right? A win. However, unwittingly, we are sailing into the perfect storm. And I'm going to take you through it, what I mean by that. First off, sorry for a bit of a flashbang here, let's put an underground under the transition. And by the way, if you're wondering, what the things I'm going to show you now happen both with the original shader and also with the adjusted shader. It's not like something we introduced. Let's have a look. See if you spot an issue. Well, it's a bit awkward, isn't it? Those who haven't spotted it. A sphere with a cube shadow? Interesting. The plot thickens again. Okay, let's backtrack a little to explain that one. This is the original clip. We just set it up. This is the same clip that I showed you before. Let's see if you can spot the issue already. Okay, I'll give it away for you. Nothing's happening there. And what did we forget? The manual does mention it, but it's so easy to forget it, especially if you're setting up multiple assets. What's going on there? We forgot to also set visibility ranges. So on the material, we've set the fade, but basically both objects continue being drawn all of the time. Very bad for performance. All the fragments are being discarded. So you have a negative impact. Now, with the visibility range set, we can see the objects go up and down outside of the transition, and the primitives go down with the lower LOD. So, life is good, right? We're there. Well, not so fast. Okay, this explains the cube shadow, because outside of the transition, the cube was still being drawn, hence the shadow. But now we've set the distance fade, we've set the visibility ranges, we've done everything right. So it must be good, right? Let's have a look. Oh, now my shadow is gone. So what's going on? Going back to the shader, this is the fragment shader, by the way. This is a post-transform vertex, camera distance. Camera distance? Well, that's interesting. What about lights? A directional light doesn't have a position. It'll have a position in the editor, you can drag it around, but as you've probably noticed, it doesn't do anything. For rendering-wise, it's just a directional vector. So when rendering the shadow maps, yeah, it's basically doing the same thing. So how to fix that? Well, before I forget, thank God for the slides. So basically what's happening, during the fade out, it's going to clamp to 0. And during the fade in, it's going to clamp to 1 in this situation. We can fix that by adding, you see at the top, don't do this dithering stuff when you're in the shadow pass. And indeed, that fixes that issue. So, nice. Life is good. Except, on to the next one. Now, life is actually good, but it's an interesting thing. Getting back to those lights, what about a light that does have a position? Well, interestingly enough, the out-of-the-box solution, what happens is, you don't move the camera. Now, if you move the lights, you could see in the shadows that it starts dithering. So introducing the little if on top of that also fixes that. And again, life is good. So, but now you have two materials, one with that little 1 minus and one without. And using more materials causes more state changes while rendering, which is bad for performance. You're doing LODs to win performance. So anyway, just for completeness sake, it's also possible to create like a standard material or one material that handles both cases depending on the direction. We're not going to go over it in detail. Somebody can screenshot it or watch on YouTube. Anyway, it's possible. So why did I call this a perfect storm? Well, because it's actually kind of nasty. Because under normal circumstances, you know, what is happening now, I brought everything to the front, but with LOD, usually you do it a bit further away, because otherwise it becomes very obvious. The user error, forgetting the visibility ranges, and then the default not having a shadow in the fade-in direction. But yeah, not having the visibility ranges causes both objects to draw. So it will look okay. In the distance, you'll see a tree and you'll see a shadow. You'll never know the difference, except that you have to, instead of increasing your performance, you basically halved it. So that was the perfect storm. Easy to walk into that one. There's an alternative solution to the shadow problem. That doesn't require any code changes to the shader, because the bad thing of doing a code change to a shader is, yeah, you don't, if Godot updates and it changes the behavior, you don't migrate with that. Anyway, I'm not going to go over it in detail, but basically what you can do is set it up that outside of the fade out, you use extra nodes. That's the basic gist. Visibility parent, okay, this is a small hub to a different construct. Intended to be used with visibility ranges, so they're kind of married. If you use this one, you need to set visibility ranges, and it change visibility. Now the docs say you can use this for a hierarchy, because if you set, a visibility parent to multiple other nodes, you can create a hierarchy. But you can also use it just with 1, 2, or 3, and this will solve your gap and double draw issues that we saw earlier. Because what's going to happen, the rendering server is going to look, okay, am I going to draw LOD2? If not, I'm going to draw LOD1. If not, I'm going to draw LOD0. So it's kind of a waterfall. There's now a relation between the two nodes. So important construct to be aware of. However, life is good. Easy to walk into. If you look up the respective property, it will be right next to the regular node visibility property. However, they are not the same. The correct way to set it up, so LOD1 would be like a multi-mesh showing 3 trees. And if you get closer, you want separate trees of higher detail, and that's better for culling. The proper way to set it up is to 3 times actually set the visibility parent. So what is the very tempting, not correct way to do it? Is you just do it on 1, and you make the other ones children. It saves you a few clicks, and the thing is, that's actually going to work. I'll show you here. So basically what will happen is 1 gets swapped out for 3. It'll work. It'll work isolated in your test scene. But again, in context, this will fall apart, and randomly, instead of now it shows 3 spheres when the work swaps out, the three spheres will randomly start appearing and disappearing. The reason for that, without going into too much detail, is during rendering, there is a certain moment where this chain is evaluated, but before that, things get shuffled. And due to the shuffle and the trigger where it's evaluated, things get messed up. I ran into this one, and that can have you puzzled for quite a while. Okay, a general thing, all of these constructs use distance as a direct metric. And this is what most people think. You know, LOD, if something is further away, I'm going to swap it out. Actually, that's a bad idea. All of the things that we just discussed have the same Achilles heel, basically. Because what's happening here, all three virtual monitors, all three of these blue spheres are 1 unit size. So intuition says, okay, left one is the closest and right one is the furthest away. Well, not so fast. It depends on the field of view of the camera. What lens are you using, basically? Not to scale, just to illustrate. So what does this mean? If you set all the things that we've gone over now, you set them up correctly, everything works, life is good, but you're implementing a first-person shooter, you pick up a sniper rifle, look through the scope, and everything is in the lowest LOD. Not so good, eh? So that's something to keep in mind. So you'll need scripting to configure the ranges, which is okay for a few nodes. But if you like 10,000 trees, if you pick up a sniper rifle and if you have to iterate over 10,000 nodes, not so much. So this is another reason why using the material is much more popular. Aside from the dithering and the alpha performance difference, if you change the material, it's a resource shared over everything, much quicker. Last but not least, the service embedded LODs. This is more API-wise. This is what is being used under the hood. If you click the import and select generate LODs, it embeds them in the mesh. This bit is much more technical. If you want to do things programmatically, I'm going to hop over it quite quickly. But anyone want to venture into this, there's some gold here that will save you a lot of time. Right off the bat, the entry point is the ArrayMesh class, so no need to search. Add service from arrays. And there's this mysterious parameter called LODs, which is a dictionary. Basically, a key and a value. So you have no name for the variable to go by. Thankfully, there's documentation, which is very brief. Okay, where the value is the mesh.array index array to use for the LOD row. Well, that clears things up, right? Crystal clear. Okay, what they're referring to is somewhere deeper in the documentation. It's a packed int32 array, so an integer array, which just like on the normal array mesh, are indices of the vertices to draw. The main takeaway is your buffer on the mesh will need the vertices of all the LODs, and the values in the dictionary are the indexes that will actually be drawn. Okay, now we get to the key of the dictionary. The key is roughly proportional to the distance at which the LOD starts being used. Roughly? Give me a number, people, come on. And this is not the best of ducks, because at first I was like, okay, that's a little fake, huh? But it's actually really good. I quickly found out. I'm not going to bore you to death with technicalities. I have a background with about 15 years of C++ experience, so I could figure things out. But okay, if we look at the function set surfaces, it's stored in a variable called edge length. Okay, naming the variable edge length wouldn't have helped anybody. And even though the math isn't that complicated, it arranges a lot of things for you. The tool long didn't read about that one, about the key. When does it swap? It's a normalized value, and it accounts for you the distance, field of view, the viewport size, viewport aspect ratio, and resolution. So that's the reason why it's not just, the issue with the other things were it was using distance. This is using, well, whatever this is, but it solves all of these problems for you. Just to give somebody who wants to try this a number, I've seen a number of Reddit threads, forum threads, etc. People are trying it, it doesn't work because, intuitively you see it as a distance, and people try, 1, 500, etc. Yeah, nothing seems to happen. It's a very sensitive thing. start with a range of 0 to about 2. And that's for about items 1 unit size. Okay, enough of the boring text and theory, because again, not everybody wants to venture into this. What I did was I created a little script that creates a mesh with LODs, and they're all cubes. And what I did was, at the highest detail level, I just inserted the vertices like 100 times, and for LOD1, 99 times, or et cetera, et cetera. So emulating that the first LOD is more difficult to draw than the other ones. And of course, for each LOD, I gave it a color, the scale is below, just to get a feel about this edge length thing, with a pink stripe in the middle to give a bit of a reference point. Let's see how that panned out. Well, okay, it works, you know. Further away, the FPS goes up, and we see the primitives go down. But yeah, as far as my colors went, I was like, okay, a bit underwhelming, right? Caution. Then I tried, okay, what if I just make a grid up until the distance, or a floor and a wall? Okay, be prepared for a bit of a LOD disco up next. Get your sunglasses out. So this is what happens. Mesmerizing, isn't it? There's probably a game in there somewhere for somebody who is creative, I don't know. Okay, enough of that. One thing that there's a takeaway, however. Even though we're working with distances, and again, the other constructs also use distance, this also under the hood uses distance at some point. Even though we think of distances, and distances relate to size, well, not so much, because you can see in the center of the screen, the pink box, it's much smaller than on the right side of the screen. Now, normally, and out of the box for the average game, that won't matter too much. But should you want to support ultra-wide screens, it can become more of an issue. Because now you can see in the center of the screen and on the right side and in the corners, ooh, big oof. That's a really big difference. And of course, in the front, it's more pronounced than in the back. But it can be disconcerting for players if they do lateral movements. If they see halfway the screen, LODs pop in and out when the distance doesn't change. So something to be aware of. One way to counter that is to give an LOD bias to push them further out. Speaking of which, this visualization also allows to show that. So first, I'll do adjusting this LOD bias. This is on a per item basis. Now I'm doing them for all of them, but it gives the general gist. You can push the moment of which LODs changes take place on a per item basis, so that's for tuning. You can also do it in a project setting. The fun thing is, what would be life without fun, right? It basically works the same, it's just that the values are the other way around. So with one, if you increase it, it will increase the distance, and here if you increase it, it will decrease the distance, or reverse. One thing to note about that, if you look at the project setting, it'll be a bit weird because it takes off about reflection probes, and we're doing nothing with reflection probes. So this is just in the tooltip. I think the normal documentation is all right. Just something, you can basically skip that. Just as a fun experiment, I created a custom Godot build with a few other projection modes, one of which is planar. Oh, you play that? Which looks like this. And also projected. Let me play that. I'm pressed for time, so I'm going to skip the commentary on how much it affects FPS, etc. 30 seconds to go. This is what planar and projected look like. So planar is very non-organic shape. It will be much more noticeable to users than the spherical one. And projected, well, the short story is that will tank your frame rate, especially on widescreens. But it's more correct because now all the LODs, it's actually an exact relation between size and LOD change instead of something to do with distance only. The key takeaway, Why is Godot the spherical selection mode? It performs best, it's an organic shape, and it's just an excellent default. So 99% of the games, 99.9, probably, unless you're doing really exotic things, might talk tomorrow, of course, it won't be a problem. So that's it. I'm 30 seconds overdue, but okay, one last comment, just scratching the surface. There's more ways to handle these phenomena. If this gets to YouTube, there's probably 100 people, oh, you can also do it like this, and this. Again, it's just to give you a heads up and you know what to look for. And it seems so simple. Hide one thing and show another. What could go wrong? Well, now you know. Thank you.